ABC Radio Darwin and the Northern Territory.
Territory inventor Stephen Camilleri cut his teeth building electronics at Parat Primary School and working on the solar car program at CDU. Now he's back at the university having invented a 3D printer that is breaking records around the world. I caught up with Stephen to see the technology for myself.
So we're currently at Charles Darwin University's Casuarina campus, and we're in the metal trades building. So this building is just finishing a refurb, and off to one corner is our 3D printing laboratory, where we're able to make metal parts very quickly and very cheaply using technology that SPEE3D, my company, has developed.
And this is a huge breakthrough in technology from existing 3D printers that have been on the market previously. Can you describe how it works?
Yeah, so when we came along, 3D printing in metal was really dedicated to making small, accurate, expensive parts. So jewellery, really. So, you know, the typical price for making a part would be in the order of maybe 8,000 Australian dollars a kilogram. So a lot of money. So we're talking 10 times the price of silver, really. Very, very expensive. So it was relegated to small stuff that needed to be exactly right. So a good example of that is like a dental crown. Not a lot of weight in a dental crown, and you want something made out of titanium, very fancy material, very precisely, so it fits in your mouth and looks like the old tooth. That's a good way of doing it, but wasn't really a whole lot of help for anything industrial. So industrial parts need to be cheap, they need to be strong, reliable, and they're typically large. And nobody was addressing that part of the market. So we thought there was an opportunity to come in and build a 3D printing technology that could make large parts quickly and cheaply.
And so how did your thinking process around that come? What kind of problems were you trying to solve?
Yeah, it's an interesting background. So myself and my business partner, Byron Kennedy, we're the founders of SPEE3D. We've come from a manufacturing background. So we were building factories around the world, many different places, for high-efficiency electric motor technology. That was something that we'd also developed. And we learned something very interesting. We learned that metal casting, which is a sort of a 5,000-plus-year-old process, this business of melting metal and pouring it into a mold to make a part, was terrible in a range of ways. So metal casting really means you're making parts in large volume. You have to make tons of parts at a time. You can't just melt, not easily, small amounts of material and make one part and one mold. And typically long lead times, a lot of labour involved, a lot of skills, dangerous, bad for the environment, a lot of emissions, and all over the world, this was the typical way that you'd make structural metal parts. And 3D printing wasn't addressing that market, and we tried very hard to get 3D printing companies interested in working with us on that, because we're having the actual manufacturing problems. Nobody was interested, the technology wasn't there, so we thought it needed to happen. So we quit our jobs, we knew exactly what the technology needed to do, and we made it do it.
How? How did you do it?
Yeah, it seems obvious from that side of it, but in hindsight maybe not so much. We knew that the technology needed to be very quick, and we knew that the thermal processes, largely thermal, melting metal, that are in 3D printing now, weren't going to have the speed that was needed. So if you want to make a part up, and the way you're doing it is you're melting material a tiny bit of it at a time and kind of making a little sheen, a little skin of material out of molten metal every time and stacking them up. You can do the equations. Physics tells you that you really have a speed limit. There's a speed limit by the side of the road, and you're not going to make parts faster than X. In this case, maybe 1/10 of a gram to a gram a minute. So that's not fast. With those processes, you're typically looking at days or weeks to make parts. And if you've got an expensive machine that takes a week to make a part, there's a lot of cost embedded in that part. It's like using an enormous truck to take your kid to school, triple-decker road train, you know. There's a lot of cost embedded in taking that kid to school versus using a push bike or a small car. So using these big, expensive 3D printers to build parts very, very slowly was just going to mean the parts were always going to be expensive and there was nothing you could do about it. So we needed to change the game. And
so you can build them with your printer at a fraction of the cost and about, is it 1,000 times faster?
Yeah, that's right. So we got the world record recently in Germany at the Formnext trade show. We actually did a live world record to prove that we could do it. We had an audience of maybe 300 people, and we built a 1 kilogram part in about 10 minutes. We built it at an average of just over 100 grams a minute. So realistically, that's 1,000 times faster than even the faster 3D printers go now. So we're claiming that as a world record. Certainly we've had no pushback on that. Nobody's even claimed to be close to that. So the way the process works is really quite different. So the trick was getting away from this thermal problem, getting away from heat. So what we did was we found a process where we didn't need to melt the material. So rather than melting the material and forming it in layers, stacked on top of each other, we take the powdered material. So we start with a powdered feedstock, so it's a metal dust, and we shoot it together with a rocket engine at about 1 kilometre a second. We take those little bits of grains of metal powder, we feed them through a rocket engine running compressed air, and the material shoots straight into the part at Mach 3, kilometre a second. And it turns out when you do that, we've done all the math and all the design, and when you do that, you get a good quality material at the end of the day.
I feel like I would love some kind of microscope into your brain, into the processes that are going around to come up with that kind of conclusion. When people talk about when they invent things that there is a kind of aha moment, was there something like that for you?
I don't know. This is an interesting philosophical question. So I'd say there's probably 2 moments, if you ask me. So the patent system relies on there being one inventive step. So people talk about one inventive step where everything changed from it being as it was to suddenly there's this new technology available. That's an inventive step. I don't really agree with that. I think that's probably 2. I think there's one where you've actually found the problem, where you've identified where the issue is. It's the little Dutch boy with his finger in the dam. That's where the problem is, right? It's right there. And the second one is when you work out how to solve that problem. And often that'll take months and appear gradually, and that's what happened in our case. So we knew that it needed to be fast. We knew that this process of shooting the material would probably do it, but there were some pretty substantial technical hurdles to overcome. So we've ended up really becoming experts in math and software. So we have a range of PhDs who do nothing but that all day, think about how to solve general problems with mathematical algorithms by building the parts up this way. So we have a robot that automatically builds the part using this rocket engine and the spray of material. I don't think a human operator could easily build a part the way that we're building it. It's a very intricate dance, and we push the robot right to its limit.
My guest today is Stephen Camilleri. Stephen is the founder of SPEE3D 3D printing, and people might be surprised to know, Stephen, that this world-class cutting-edge technology is happening right here in the Northern Territory in Darwin.
Yes, that's right. The prototype's here in Darwin, the very first one that we ever got to work. We really do all of our R&D here, so our key R&D happens here in Darwin. And I mean, Darwin's a great place to be doing this. So I often do get people ask me, what are you doing in Darwin? This doesn't make, why aren't you off in a big city? Why aren't you in Silicon Valley? And the answer is places like Darwin give you that headspace that you need to sit down, be properly creative for hours at a time, without distraction, without too much stress of traffic and, working out how you're going to get your kids to school 30 kilometres away, all that sort of stuff. Darwin doesn't have any of these problems. So we can really get into it quite hard here. In places like the US and Europe, it's relatively normal to have a small town with, clever people working on some joint goal. And, you see small towns with big companies attached to them all the time. It's pretty normal. So I guess it's not a thing that's ever been an Australian normal, but that doesn't mean that it's something that doesn't happen. Like you see this all over the world. Companies like, John Deere, Caterpillar, even GE, Silicon Valley was just a beach town before all the silicon guys got into it. And Darwin, I think, has the potential to become something like that. And we certainly find we can do our best work here.
And you actually grew up in Darwin as well, so there's that historical legacy for you.
Yeah, that's right. Yeah, I went to primary school and high school and university here. And when my first company was bought out, the electric motor company, they relocated us to Melbourne. And I was there for a few years. And, I didn't mind Melbourne, but I found that I couldn't do what I could do in Darwin. So I moved back.
How do you think Darwin shaped you as a thinker, as an inventor, as an engineer?
So part of this is really the general Australian story. So I think we're quite good at being problem solvers and being a bit irreverent. And I think that's an interesting mix. So, a lot of people who know think of Australia as an innovative place. So the Japanese, for example, would think of Darwin as an innovative place. I'm welcomed as an innovator by being Australian when I visit companies over there. That doesn't happen in the US. Interestingly, we don't have that same cultural perception there. But, if I'm going to walk into Toyota and say to them, you're not making your parts right, I think I've got a better solution, there's an element of arrogance there that I think we probably are born with or just kind of inherit. And I'm not sure that a lot of other countries would have the same cultural willingness to go to that kind of place and do those kinds of things.
I'm interested to know what your sort of founding influences in the territory were, teachers, schools, programs that shaped you.
I was very lucky to go to the gifted unit at Prep School when I was a kid. So I think that probably saved me in many ways. I don't think I was doing well before I went there, but being around other gifted kids and working out that while I was weird and kind of off-putting to a lot of people, they were in the same boat in many cases, and we got along very well. I've got lifelong friends that I still talk to every day from that gifted unit, and I do regret that there are kids growing up in places that don't have access to that stuff. Like, that just feels like a huge missed opportunity. When I was at primary school, in fact, I did Year 12 electronics. So Darwin High School opened up to the gifted unit, and we went there and did some courses, and I got 100%, and I ended up getting the Administrator's Award or something like that. I can't recall what it was. It was a while ago now. So I'm in a government house with 100 other Year 12 graduates, but I'm 11 years old, 10 years old. So that was a very strange experience that I still remember as being very strange. But, this is the kind of thing that does happen in Darwin. We talk about Darwin effect. I mean, I can go and talk to oil and gas people here pretty much anytime I like. We're pretty casual about that. We have a great relationship with Defence up here. So the Navy contract got announced at the end of last year, and we're doing all of that work here in Darwin. Now, I don't know if we were in, Melbourne or Sydney, whether those opportunities would have really been possible, because, the processes of getting in, competing for oxygen time with Defence are much more difficult. And, up here, not only do we have, this relaxed casual nature that lets us go and meet these people, but we also have a bit of willingness on the other side to maybe be engaged with the community because the community is smaller, and, and a bit more willingness to think about what might be possible. Whereas I imagine at the big bases down in Melbourne and Sydney, everybody's concentrating on what's in front of them. It's all somebody else's job, somebody else's responsibility. And so I think we have this interesting mix here where you have good people that are willing to talk to you and willing to try something. And, the technology that we've developed, this metal 3D printing technology, suits a location like that really well because we're able to solve those problems that traditionally have been plaguing us.
And the other territory program that was really formative for you was working on the solar cars, wasn't it?
Yeah, that's right. So that was actually with the university. So I did get a scholarship to go to a different university in Western Australia, and I ended up knocking it back because the solar car project here was of interest to me. So I stayed here, worked through that my entire undergrad, and then I actually got employed at the university here to work on technology that I developed with the solar car, and that kind of shaped my early career.
What kinds of things were you developing at that stage?
So the high-efficiency electric motors and the high-efficiency electronics that interface between the solar panel and the motors and the batteries and things like that. So my specialty is actually power electronics, not something that I use much in 3D printing. But what the solar car project did for me was give me some emphasis to think about efficiency and, not wasting resources, not wasting material, not wasting energy. And when you're working on 3D printing technology like this, in fact, we have a lot of electric vehicle industry people in our company, and that's probably no coincidence. The people who are thinking about sustainability and renewable energy are the people who are thinking about minimizing waste and doing things efficiently. And at the end of the day, what we're actually talking about there is cost. If you want to be a good manufacturer, you've got to understand how to control cost. It's quite interesting that this next wave of industrialists that I kind of see coming is all of these people who understand that solar energy is a very cheap way to be generating energy, much cheaper than other ways of generating energy, and are going to do that simply because the sustainability and environmental side of it is the bit that makes it commercially successful. I do think we have a bit of a problem in Australia with this kind of unfriendliness around renewable energy and energy efficiency, whereas in reality, these are all quite natural elements that make good industrialists and good developed nations.
It strikes me that this is such an interesting creative melting pot. You've got so many things happening: technology, philosophy, the environment, energy, resources. What does it do for your creative brain, that boy who was 10 or 11 and winning the electronics process? Is this just the most exciting workplace in the world?
Oh, absolutely. I don't really know how people do it in big business. It's certainly not for me. I struggle to kind of sit into one pigeonhole. So really, it's always been about having my own business and developing something that I thought was socially important, as far as I'm concerned. I appreciate that's not the case for everyone, but I couldn't not be doing what I'm doing.
Can you give me an insight into your creative processes?
Creative processes. This is an interesting question. So, interestingly, I didn't really particularly think of my job as a creative job until fairly recently, but it really is. I've met a range of creative people just to investigate this personally, to satisfy my own curiosity. But, we do need to create something from nothing. That's how technology development is. So, this isn't about just, going up to Bunnings and buying some stuff and whacking it together. This is about really quite deliberately planning for something new to happen. And that's what a playwright does. It's what a songwriter does. It's what an artist does. And, a lot of this stuff doesn't happen by accident. I'm sure you've interviewed many creative people. And I don't think, maybe tell me, has anyone ever told you, it just happens, I just wake up and the canvas is there and I just let it happen and then it's done.
If they ever told us that, we'd probably have to, take them out the back and...
Yeah, that's right. I don't think that's the way it works. I mean, all of the creative people that I know that are very successful, it's quite a deliberate process. And in fact, I've compared notes with some of them and the creative process would appear to be very similar. So it's this business of, first of all, understanding that something needed to exist that didn't. So this is the kind of the philosophical step. So what is it that needs to exist? Why doesn't it exist now? Why hasn't somebody else done it already? Let's try and plan the best version of it that we can. Like, let's try and do some good with it. Just like with doctors, you don't meet artists that intend to do harm. You meet artists that intend to do good. And really, this is exactly the same situation. So we want to do something that's beneficial, that makes life better in some way. And our company motto is that we want to make manufacturing easier. And that's really what we do. Everything we do pushes in that direction. But, you have a talented painter. They've got a vision for something that needs to happen. There needs to be a painting. It's going to endure, and the painting needs to have these elements in it, and needs to be constructed a certain way, and needs to drive this kind of emotion in the viewer. And I think we really look at it very similarly. So we've got people who have problems. They go to work every day. They make something. They have trouble obtaining a part. They have trouble keeping their ship on the water, keeping their plane in the sky, whatever it might be. We want to make sure those people can interact with our process successfully. The painting that we've done is the right one. When they look at it, it actually helps them. It's beneficial. So, of course, there's a lot of technical detail underneath that. But to be honest, that actually isn't the hard part. There are plenty of people out there everywhere in the world very good at the technical detail. I think the creative element's often understated when it comes to new technology development.
And tell me, Stephen, what's next for you guys here?
Wow, it's a complicated question. At the moment, we're very heavily focused towards getting our product in people's hands. So we have this printing technology. It works. We've been working with Charles Darwin University here for many years. A lot of people have come through. A lot of problems have been solved. A lot of parts have been made. People, are now coming to where we think was the right conclusions, that the technology is not hard to use. It works just like other technologies that make metal parts, but gives you interesting new angles on that. And, it's a matter now of getting that in front of the right people. Now, we have the same problem that I'm sure every other Australian technology company has, that we're very isolated here. So we do have this perfect storm in Australia, I think, for innovation, and I think Darwin in particular, where we can clearly see what it is that needs to happen, and we have the skills to make it happen. But, we don't really have the kind of market here to scale a company successfully. We have to go international. And so basically we have to, if you like, hatch out of our egg and then immediately fly out of the nest, fly all around the world and make this product a commercial success. So other countries often don't have to do that. They can deal with, everyone within 100 kilometers or 100 miles radius, if we're talking about the US, and, successfully grow their company that way. And we can't really. There's not enough business in Australia to sustain a company like us. So we need to grow up awfully quick. And we're very lucky that we've done this once before, so we know that that's absolutely a priority. So we spend a lot of time on planes. We spend a lot of time talking to rooms full of people in suits. And it's all about getting the technology into people's hands and making sure that it works.
That was Territory-born founder of SPEE3D, Stephen Camilleri. As you've been hearing, he's one of the brains behind a 3D printer that is changing the global conversation about parts manufacturing. I interviewed Stephen at his workshop at Charles Darwin University.
Hear the